Yeah, hi Tomasz.
Hello.
Hello, and also we're waiting for Zhenya, who would moderate this talk. So I think he would join us shortly
Hi,
once he
Roman.
turns on
Do you
his
hear me?
video. Yeah, we can hear you, but we can't see you. Okay, nice. Now we can see you as well. Hi guys, how are you? I want to say that before this conference, we have a voting for the most weighted talk. Yeah, the talk which our audience weighted more. The Tomasz talk gained the best result. I don't remember the concrete numbers, but let me just check it really fast. So, just a second, I'm checking. So yeah, 125 points. I think that's really nice. So, could you tell us just in few words what your talk would be about?
Okay. First of all, I haven't asked my friends to vote, so I'm happy that my presentation is voted as a top one. This presentation will be an introduction to the application monitoring, and this will be a perspective of a developer, because I'm a developer, so I know how to instrument the application and how to monitor the application. I will not share the knowledge how to monitor the infrastructure. I have of course, some basic knowledge regarding this and also the experience with using the dashboards with the monitoring for a storage or for network, but it's not my primary focus. My primary focus will be to introduce, to show what we need to do as a developers to expose metrics, to collect metrics, and in general, to understand what is the monitoring solution, what are the components of the full solution. So that will be my main goal.
I think it should be super useful for everyone. So, Zhenya, question to you: how often do you use monitorings in your projects?
Oh, actually, it depends, but we are trying to use it everywhere. Yes, and also it's not only a Spring Boot, I would say, monitoring part. It's also some generic solution, and yes, I think it's really useful. Stuff.
Okay.
I will also explain why in my opinion, is important for developers to at least be familiar with monitoring on the basic level, because we don't need to monitor our application on the production. We can use a monitoring on our local environment just to verify and to measure the memory in as easy way as possible, right? Because everything is out of the box, as in Spring. We are used to that in Spring. We have a lot of out of the box solutions. The same applies for monitoring. But of course, we need to do how to start with this. And this is exactly what I am going to present, how to start with monitoring.
Yeah, Thomas, I'm a little bit familiar with your presentation, and I think it will be a great basis for a great common knowledge for the start. Yes, with monitoring.
Okay, so I think we may go to the presentation itself and start the talk. Before that, I would ask Tomasz to share his screen so our operator of our broadcast would be able to prepare everything. And before we start this talk, I want to say that we have special chat in Telegram for questions for Tomasz, and please type your questions there. The link already appeared in the main channel or in main Telegram channel of our conference and will shortly appear in YouTube. So join this chat, type your questions there, and in the end of the presentation we would ask this question to Tomasz, and also there would be discussion room, and in this room these questions also could be asked. Okay, that's it from my side, and I pass the voice to you, Tomasz. Good luck.
Okay. First question, do you see my screen? Is everything okay with the presentation?
Yeah, yeah, we can. Everything is fine.
Okay. So let's start. Welcome to my presentation. Today, I would like to share with you application monitoring. I will focus on this presentation. Introduce myself. My name is Tomasz, and I am employee of EPAM. Yep.
Yeah, I'm sorry to interrupt you, but we have some technical problems, seems, on your side with internet connection. So is it possible to do something with that?
Okay, let me try. Currently,
Yeah,
I'm
sure.
in the office, so it should be the best internet connection that I can provide.
Yeah,
so
no
Wi-Fi,
have...
only no Wi-Fi. It's just a cable.
Okay. So now it looks like everything is fine. So
yeah, okay.
Sorry for interruption, and guys, sorry for this technical issues.
So please interrupt if you notice any problems, right? Because I will do my job, and please just raise the problems, okay?
Sure. I disappeared.
Yep. Okay, let me introduce myself. My name is Tomasz, and I'm employee of Gdańsk office for more than 5 years. Currently, I'm a Java developer, but with experience in other stacks like PHP or .NET. And after work, I like to participate in obstacle course races or play drums. During my speech, I would like to introduce you to the subject of application and infrastructure monitoring. I will guide you tools that can be used to build your monitoring solution. We will discuss some general view and definitions, then MICROMETER as a Java library application, Prometheus as a time series database to store data, ALERTMANAGER as a component for alerting and notifications, Grafana for visualization, and I will end my presentation with a demo.
Yeah, sorry, that's me again. Yeah, just a quick question. Is your laptop connected to electricity?
Yep.
Okay, so maybe we may try to turn off your video. Maybe that would be better, because I would say that would sad that we won't see you, but we will hear you well.
Okay, sure. I will stop my camera.
Okay, so let's try in this configuration.
Okay, sure. Okay, so what is monitoring? Monitoring is what I am doing on a daily basis, and one could say that I'm constantly looking at graphs, deriving satisfaction from how great my applications work. But this is only the half of the truth. In practice, I'm using monitoring to constantly improve my skills, quality of my applications, and the monitoring solution itself. Today, I will show you what to do to reach this point. More formal definition is that monitoring is a process of collecting, aggregating, and analyzing data that is exposed by a system or infrastructure. And those data are called metrics. The most important thing to remember is that monitoring is not logging nor tracing. In case of monitoring, time series data are collected, and there are just numbers. Log data includes more information about the event that took place, and tracing data is like log data, but for events that go through several applications. Monitoring applies to production applications, so why should developers take care of it? It has been assumed that development team is only responsible for developing new features and bug fixing. after the code is put to production, the external team is responsible for monitoring and maintenance. But nowadays, especially in the world of microservices, the development team gets more responsibility. Very often, we are given full ownership of product development and maintenance. This means that we, as a developers, need to configure and then use proper tools. And one of these tools is a monitoring solution. And there are many reasons to monitor a system. Monitoring allows us to be proactive. We can try in advance protect our system from failures. It can help us to monitor our service level agreement and react to any problems before customer will notice. The system should be viewed as a whole consisting of many components, which is why we should monitor not only our applications, but also the infrastructure and the network. Only the full overview can give us quick answer regarding the root of our problems. Let's now look at how it may look monitoring ecosystem. What we have is, of course, our target infrastructure and application we'd like to monitor. Our data need to be stored somewhere, and we need a solution for that. What is worth highlighting here is two models of metrics storage component. In a pull model, metrics are scraped from targets. In a push model, data needs to be pushed to storage component. And there are additional components for visualization and alerting. There are lots of providers of those components with different characteristics, but my choice is Prometheus, ALERTMANAGER, and Grafana. My goal is not to convince you that this is the best choice, and you can successfully use tools from other vendors. The ones I choose are commonly used, and there is a lot of knowledge about them. So our target environment consists of Prometheus, ALERTMANAGER, and Grafana. Those components are open source and community driven. And we'll use a Java MICROMETER library to instrument our application and expose metrics. Let's take a closer look at how on the library used to instrument the application in Java. You can think about this library as SLF4J, but for metrics. It means that you don't need to care about your target monitoring system. In fact, metrics can be exported to more than one system, which I will show you on demo. MICROMETER supports dimensional metrics for timers, gauges, counters, distribution summaries, and more. On the next slide, I will explain you what dimensional metrics mean. MICROMETER is a Java library integrated into Spring Boot and auto-configured by Actuator, but it can be used in any Java project. Now I will explain the difference between hierarchical and dimensional metrics. Hierarchical metrics are identified only by their name, consist of dot-separated dimensions. It means that multiple metrics need to be created to cover all combinations of dimensions. And some metric storages support only this type of metrics. In contrast to this, dimensional model is flexible. A metric is identified by name and dimensions. Those dimensions allow a metric to be sliced to drill down and reason about the data. Now let's look at the most important components of this library. In MICROMETER, a meter registry is the core component used for registering meters. The library supports a variety of monitoring systems by implementing specific meter registry. And each meter registry provides a solution to publish application metrics to supported monitoring systems. For example, Prometheus meter registry exposes metrics in Prometheus format, and those data can be scraped by dedicated endpoint. A meter is the interface for collecting a set of measurements, which we individually call metrics. And different meter types result in a different number of metrics generated. For example, there is a single value that represents a gauge or counter, but for timer, there are two metrics: total count of events and the total time of all events. Meter binders are ready-to-use utilities that collect metrics from the most common resources. The MICROMETER implements multiple built-in binders to monitor JVM, logging events, Tomcat, and much more. In Spring, those binders are auto-configured. Each registry can be configured with meter filters, which serve three basic functions. So we can deny or accept meters from being registered, or we can transform meter by changing a name, or we can add tags, change a description or base unit. And finally, we can configure distribution statistics for some meter types. Let's review the most important features of Prometheus. Prometheus is a pool-based monitoring system and time series database that supports multidimensional data model. It provides a functional query language called PromQL that lets the user select and aggregate time series data in real time. And there are a lot of libraries which help in exporting metrics from third-party systems in Prometheus format. Some of these exporters are maintained as a part of the official Prometheus organization. Prometheus offers a service discovery for discovering targets, including Kubernetes, Consul, and many others. Prometheus is not dedicated to store logging or tracing data, and it doesn't provide any sophisticated logic for automatic problem detection. Let's review the simplified architecture of Prometheus and some its ecosystem components. Prometheus Server is the heart of our monitoring system. The data are stored in local time series database, but it is possible to integrate with remote storage systems. And the local time series database stores data in a custom, highly efficient format. Scaling is achieved by sharding or federation. Configuration contains static target definitions, aggregation rules, and alert definitions. Prometheus can be integrated with a service discovery to fetch targets dynamically. metrics are scraped directly from targets, such as our applications, exporters, or push gateway. And of course, we can integrate with the UI like Grafana and ALERTMANAGER. ALERTMANAGER is component offered from Prometheus team. Prometheus stores all data as time series, which is as streams of timestamped values belonging to the same metrics and the same set of dimensions. Every time series is identified by its name and optional key value pairs called labels. The query language allows filtering and aggregation based on those dimensions. Prometheus provides a functional query language that lets the user select and aggregate time series data in real time. Here you can see examples of queries for request rate, errors, or request duration. There is also a simple UI for Prometheus. There is an expression browser where you can enter your expression and see its result either in a table or graphed over time. But this is primarily useful for ad hoc queries and debugging. For more complex visualization, the Grafana is a recommended tool. Now we'll discuss alerting capabilities of Prometheus and ALERTMANAGER. We already know that metrics are pulled from targets and that alerting rules are defined in Prometheus Server. Prometheus evaluates rules and sends alerts to ALERTMANAGER. Then in ALERTMANAGER, we can define the actions and manage alerts. For example, silencing is to mute alerts for a given time. Inhibition is to suppress notifications for certain alerts if other alerts are already fired. And grouping groups alerts of similar nature into a single notification. And of course, ALERTMANAGER sends messages to defined receivers. Here you can find example of alerting rule. Those rules allow us to define a condition based on Prometheus expression language. The labels allows specifying a set of additional data to be attached to the alert. For example, based on the severity, we can route alerts, for example, to first level support team or on team Slack channel. The annotations specify a set of labels that can be used to store longer additional information such as alert description or runbook links. And the label and notification values can be templated. ALERTMANAGER also offers simple UI where we can list and manage alerts. The last but not least component is Grafana. And we can say that Grafana is just a visualization tool, but it is such a powerful tool that it would take several such sessions to cover it in details. Grafana is recommended by Prometheus team, and both companies cooperate to deliver the best solution. Grafana includes built-in support for Prometheus. Okay, time for demo. I've created a demo microservice that is already running. I will run JMeter to generate some traffic. Let me do this. Okay, we can see that our application is running and we have some messages. In my application, I am using Redis as a caching solution, but just to show you how we can monitor Redis instance by using Redis exporter. I've also started Prometheus, Grafana, Redis, and Redis exporter on my local machine. I will skip configuration of this tool, but I just run binaries with default configuration. Of course, you can also use a Dockerized version of those tools. So let's first review the code of the application. From dependency point of view, we need, of course, the actuator to auto-configure MICROMETER and expose metric endpoints. I've also added 2 registries to expose metrics to Prometheus and also to expose metrics as JMX bins. And I added some Redis dependency to use Redis. By default, metrics endpoint are not exposed, and we need to do this explicitly in a configuration file, just like other functionalities in Spring. So monitoring behavior can be configured in a configuration file or by Java configuration. Here is an example of a configuration of distribution summary by using a configuration file. And in general, that's all we need to do to collect and expose metric from our application. But I've added some additional Java configuration just to show you how it can be applied. We can use a Meta registry customizer, or we can just create a Meta filter bins. I added a configuration to add a common tag with the application name, and I also deny some metrics to be collected for favicon. And here I also added some configuration of distribution statistics. I've added percentiles. And my application contains one controller with a get method producing successful or error response based on the response from the service. In a service, I'm generating a random number and I'm using cache to store its multiplication. And based on the value, we generate the error message or warning, and also I increase a custom counter. Here you can see the example how we can implement our own counters. So we can imagine that we can add our own counters to, or not only counters, but also our own metrics to measure some business value and business behavior. The multiplication service is very simple. It's just multiply the value, and this is only to to use Redis as a solution to show how we can also monitor Redis. The statistical average value I generated should be 200. So average response time should be 200 milliseconds. I run JMeter with 4 concurrent users. So in total, we should achieve 20 requests per second. And 25% of calls should fail. And later we will see if my assumptions are correct. I will stop JMeter now. Okay. Let's now review the endpoints to expose metrics. But before I will jump to those endpoints, I will show you the official site of Prometheus with the list of the exporters we can easily download, install, and use. So it's quite a long list. The most popular databases and solutions are covered. Okay, there is a default actuator metric endpoints with a list of all metrics. We can now choose one and see details. So, for example, here is the JVM memory used, and with the value and with the tags. The tags is the same as labels in Prometheus. So we can see that this is a total value of memory used, but we can drill down, for example, to see only the usage for a heap memory. So we can use a query just to filter by using a tag area heap. So currently, it's only show us a used heap memory. The endpoint for Prometheus. This is an example for. Okay, let me Prometheus. Okay, so this is the endpoint for Prometheus version. It's just a text file with the same metrics, but in a different format. As you can see, it's the format I described to you in the presentation. So we have a name of a metrics and a labels. And as you can see, the all combination of the labels are exposed as separate values. So, for example, for memory usage, we have all combination of the area and ID, and all individual data are exposed. Here is the metric endpoint from Redis exporter. So you can see Redis specific metrics like the number of commands, the number of DB keys, a lot of valuable statistics and data that can be later used to prepare our graph. Okay, this is the UI for Prometheus. We can list our configuration. For example, we can list our rules or targets. This is our target of our application. There is a state. We know that it's up. We know when it was last time scraped with the metrics and what was the duration of the scrape. There is also an endpoint for a metrics exposed by Prometheus. So Prometheus also expose a metric endpoint. It means that we can, for example, set up an additional Prometheus server to monitor our main Prometheus server and our monitoring solution. There is also a Redis exporter as a target to scrape data from a Redis exporter. And those targets I've added by editing a very simple configuration file. It's just a text file where we can easily add new targets. There is also a very simple expression browser where you can play with your queries and ad hoc queries. Let's check the same JVM memory used. Okay, we see all combination of JVM memory use metrics, but let's assume we would like to only display for a given area, or even let's group by area. So we can use, for example, some sum by area. And now we see a memory used grouped by area. We can also graph over time the usage of my memory. But as I already said, this is convenient for some ad hoc queries, for debugging problems, for more complex scenarios, more complex dashboards. Grafana is a perfect tool. And now we could create a new dashboard from scratch, but it will be a time-consuming task. It's better for the purpose of this demo to use pre-built dashboards from Grafana.com. Official Grafana on the official Grafana page, you can find a collection of shared dashboard you can download and use with a standalone instance of Grafana. I've already choose a proper one, this one for Redis, so I can just copy a link and click import. Then I will select the data sort and import the dashboard. Okay, and as you can see, by one click, just by importing the existing dashboard, I have quite fancy, nice overview of a behavior of my Redis instance. We see how many memory is used, how many clients are connected, the command executed per second, memory usage, some network statistics, what kind of commands were executed. Quite nice dashboard. Let's now import the second one for Spring Boot statistics. There are several dashboards you can use, but this one I like the most. So let's import the next one. Okay, and here we have the some basic statistics with the uptime of our application, with also the usage of memory, with a CPU usage, What's more? We have JVM statistics for memory. Some more JVM statistics, this time for a garbage collection. Okay, some Hikari, but we are not using it. So, and then we have HTTP statistics. I've said that it should our application should generate about 20 requests per second, and it's already true, because in total it's more or less 20 requests, and 25% of requests are failing. So we have a request per second for 200 responses and for 500 responses. And we have also the response time collected. We have some Tomcat statistics with the sessions, with the thread that are used and utilized. And we have our logback statistics with the number of errors and with the number of warnings. Quite nice, comprehensive dashboard just by importing the existing one. Of course, now we need to spend some time to tune this this dashboard and configure it for our own preferences of what exactly we need to monitor, what would be useful for us. As far as you remember, I've added the Prometheus dependency register, but also JMX. So now I will open the JConsole. I will connect to my demo application. And we can see that there is a metric, and exactly the same metrics are exposed as JMX bins. And we can also check a value of a given metrics. For example, JVM memory used. Okay, and there is a value for a given metric. I hope that this introduction has shown you that we can easily and quickly start our adventure with monitoring. I wish that your graphs and alerts will not cause you a sleepless night, but will bring a satisfaction from well-written code. Finally, I would like to share 2 my sentences. Don't miss the opportunity to improve your code and skills based on monitoring feedback. And the most fancy dashboard is useless if you don't understand your data. Okay, thank you. And time for question. I hope the connection was better and you were able to follow the presentation.
Yeah, we were. Thank you very much for this presentation. I hope it was useful. At least I saw some comments in YouTube chat that good choice to use Prometheus with Grafana. So thank you very much for your presentation. I want to remind guys that we have special chat where you may post your questions. So don't miss a chance to type your questions there, or you may try to type your questions even in YouTube chat. We're reading all these sources, so type your questions anywhere, so we would be able to ask them to Tomasz. Zhenya,
Yeah, till we wait some questions from guys and from listeners, let's maybe discuss a couple of also things. Actually, I have a question to you, Thomas. Am I right that Grafana and Prometheus provide this alerting functionality out of the box, and there is no additional charge, right?
Yeah, there is additional component Alert Manager, right? But it's Prometheus and Alert Manager are components from, let's say, the same supplier, so we can easily integrate. And this is a separate components we need to install and maintain. As I explained during the presentation, the rules, the alerting rules are defined in Prometheus, and then based on the data and the metrics, those rules are evaluated, and then the alert is triggered to Alert Manager. But then in the Alert Manager, we can define some actions. Because imagine there is a crash of the whole infrastructure, and suddenly we have a lot of alerts with a different components. But there is only one reason of the alert, right? There is a root reason that our whole infrastructure is down. But all individual components are producing alerts. But in Alert Manager, we can define some kind of a behavior that will group alerts or will stop sending notification based on some condition. So if there is an alert regarding the problem with the whole infrastructure, then there will be only one alert, right? We can define some kind of this kind of behavior, not to populate tons of alerts on our channels. And from my perspective, in my current project, developers are responsible for setting the alerts, and it can be any type of alerts. Recently, we configured the alerts for a certification expiration period, right? Because we face the problem with some date of the expiration of the certificate, and we configure alert, and we are notified a week before the given certificate is going to expire. We created our own custom metrics. It's a shared tool that can be used by any other team, just to collect some metric regarding the time to expire.
Okay, understood. This Alert Manager it's for free, right?
Yes.
Because,
yes.
For example, for Elasticstack, some kind of extension like XPack, it's also
it's open source. In fact, Prometheus currently is a kind of a standard for Kubernetes, right? So if you are using a Kubernetes, you definitely will use a Prometheus with the whole stack.
Okay, thanks. Yeah, and maybe one more question from my side. What will be the, let's say, some common set of metrics that you recommend to use on the project, like a best practice?
Yeah, there are some methodologies, I could say, like RED method. It means duration, requests per second, duration, and errors, right? So basically what you should care is the request rate, throughput, and errors. But of course, it's a good practice is to split your dashboard in a section. You have a general overview with the only main, let's say, indicators of the health of your system. And in case of any problems, you can just expand expand the other panels with more metrics like database, right? Because the first view will give you the information, okay, something is wrong, but you don't know what exactly, right? But you already know that something is wrong, which is good. Just a quick overview is enough on the basic metrics. But then you can expand other panels like database statistics, or what is very important, we should monitor calls to external services, right? So one quick look at the external services communication, and you can know that this is not a problem of your application, but the problem of the external service you are calling or you are using, or external tool, or external database, storage, network. That's why it is important to use the dashboards also prepared by other teams, like the infrastructure team, the tools to monitor the Kubernetes, for example, platform, because you can struggle with some problems, but just one quick look at the dashboard with the cluster of Kubernetes, and you can know, okay, it's not a problem of my application, it was a global problem with the Kubernetes cluster, right? So that's why you should know what exactly are steps from let's say the overview to the details.
Yeah, as I understood, you recommend to define some high-level dashboard, right, for the metrics, and also define some more detailed views for these metrics and possible problems.
Yeah, exactly. And good practice is to have the detailed graphs closed. Why? Because if you open a Grafana page with all the all the graphs opened, then it will call a Prometheus for a data, and sometimes it can be it can be time consuming, or it can be quite expensive query to execute. That's why if you open a dashboard, maybe as I showed you, I have in the dashboard I imported, there were panels I can collapse with a basic, with JVM, so I can collapse open and close, right? And by default, we should have all the panels closed, not to ask Prometheus for a data. And if I need some specific data, I can open a panel, and then the graph will be we'll call Prometheus for data, and I will have what I need.
It's a good point. Actually, I never thought about this point when you need to execute actually additional queries, and it will be also some maybe performance degradation for this case. Cool.
Yeah, I have a small question from my side. Of course, it's not like the part of your talk, but maybe you could give some notes here, some hints. So here we're speaking about some infrastructure which we define by ourselves, but if we speak about cloud, maybe some cloud solutions. So do they have some in-house solutions, or we need to take Prometheus and put it in our cloud infrastructure as well?
Maybe I will explain how it is organized in my project, because we are using the Kubernetes in LWS, and we have the Prometheus installed there. Of course, there is LWS has its own monitoring solution, right? But the Grafana is a kind of a centralized way. We can use only one UI. With the all data we need, and what we can do, we can even install Redis exporter for Redis provided by AWS, right? And we can easily integrate. So it's not a problem to install any additional components on AWS and to monitor managed services and expose metrics. This is approach we currently configured in my current project.
Okay, okay. Thank you very much for the answer. I don't see a lot of questions, so guys, please take a chance to pass your questions there, or you may just go to Zoom room and ask your questions directly. I hope you will be there with Tomasz. So, saying that, Tomasz, thank you very much for your talk. I think it's really useful, and it was really nice to having you on this conference. Zhenya, thank you very much for your moderation.